Okay, we want to find the area moment of inertia of this area about the x-axis. And we're going to do this very similarly to the way we did centroids in that we're going to draw a thin rectangle. Now, the thing is we want to draw this thin rectangle a very specific way, whereas centroids you kind of do either way. But this one we want to do parallel with our axis. So we'll draw this horizontal thin rectangle like this. And the reason we want to do that is so that the entire area is some distance that we're going to call y away from the x-axis. This will have a thickness of dy, and then it'll have a width of x. That'll vary as I move up and down my y-axis with that. So um, the equation that we use for the moment of inertia about the x-axis is the integral of y squared dA, okay, where dA is equal to the length times width of my value here, which is just going to be x times dy, which is what dA equals. Now, again, the problem here is I need to get everything in terms of y here because I'm going to integrate with respect to y. So I'm going to take my equation that's given here, okay, and I'm going to say, okay, I'm going to solve for x essentially. So I get 2x cubed equals 2 minus y, okay, and then I'm going to go ahead and divide by 2, which will give me 1 minus y over 2, and then I'm going to take a cubed root. So that'll be to the 1/3 power, like so. That is what my x value is. That's what I'm going to then plug into my equation up here. So I have y squared, and instead of x, I'm going to have 1 minus y squared to the 1/3 power times dy. Just now I've got everything in terms of y here. I'm going to integrate with respect to y dy. So I'm going to go from 0 all the way up to 2 inches on this. Okay. Now this is an integral that I can't probably solve by hand. You can plug it into a calculator if you want. It is a solvable integral for those of you that know how to do that. And you'll get 1.54. Now the units on this, again, are y squared times an area. So it's going to be that inches to the fourth, which is a challenging set of units. Okay, but those are the units for the um, area moment of inertia. So again, similar to centroids, except you draw a very specific thin rectangle and apply the appropriate moment of inertia equation and get everything in terms of the same variable and do your integral.